All right, let's dive into something pretty amazing. We're talking atomistic simulations today, getting really, really small, like atoms and molecules small. And believe me, it gets complicated. But that's where Deneb comes in, like a secret weapon for scientists.
Exactly. Deneb is designed to solve a big problem. A lot of scientists, they struggle with tons and tons of data. Like imagine keeping track of thousands or even millions of atoms in a simulation. It's a lot.
Whoa, yeah, that's like herding cats, digital cats. So how does Deneb actually help scientists do all that? I'm imagining something super organized, like a perfect lab assistant that can find anything in a second.
That's a great way to put it. Deneb has these three main tools: Nano Explorer, Sample Manipulator, and Project Browser. And each one is like a key part in making these simulations, which are really complex, way easier to set up, run, and understand.
Okay, a scientific trio. I love it. Let's break them down one by one. First up, Nano Explorer. What makes it special?
Nano Explorer is all about, you guessed it, organization. It's basically a giant searchable database, right? And it's for all your samples, which are like the digital versions of the molecules and stuff that you're simulating.
So, like, if I was researching those carbon nanotubes, the ones they use for the really advanced electronics, each nanotube, that'd be a separate sample in my Nano Explorer collection.
Exactly. And the best part is you can organize all those samples in a way that makes sense for what you're researching. You can group them, tag them, even search by specific properties. It's about making that mountain of data actually usable.
Wow, so it's the difference between digging through a messy toolbox and having a perfectly organized workshop. Huge time saver. Okay, what about this sample manipulator? What kind of manipulation are we talking?
Okay, this is where it gets fun. This is your virtual lab bench. Literally, imagine you're holding a molecule in your hand and you can rotate it, zoom in on like a single atom, even measure the distances between them. Need to stretch a bond or build something from scratch, atom by atom. You got it.
Sounds seriously visual. Can you actually see the molecules and like move them around in real
Oh,
time?
yeah, absolutely. Remember those X, Y, and Z coordinates from back in school? Well, they're back, but DNF makes them surprisingly easy to work with. You're visualizing atoms, their bonds, even measuring distances with a click. It's next level stuff.
Wow, hands-on research takes on a whole new meaning. Okay, we've checked out our samples in Nano Explorer. We've tinkered with them in Sample Manipulator. So where does Project Browser fit into all this?
So think of Project Browser like mission control for your research project. This is where everything comes together, right? You got your samples all prepped and ready, and now you add in all the other important details that set up your simulation. Things like temperature, pressure, you name it.
So it's like setting up the perfect conditions in a virtual lab, making sure everything is exactly right before you start the experiment.
Perfect analogy. But here's where it gets even cooler. Project Browser doesn't just help you define the simulation, it can actually run it for you.
Wait, really? So I can run a simulation on, say, a supercomputer, but from my desk, no need to go anywhere.
You got it. DNeb handles it, all the connection, sending the job, monitoring it, and even getting the results back to you.
That's incredible. No more waiting in line to use those expensive computers or messing around with complicated installations. It's like having a direct line to a supercomputer, all thanks to Deneb. This has got to be a game changer, especially for scientists working in smaller labs or those who don't have tons of funding.
Absolutely. It makes these high-powered tools accessible to everyone. So now, more scientists can tackle those really big, complex problems that need solving.
Wow, that's a game changer for sure. DM's got your back from setup to supercomputer. But what about after the simulation runs? Does it help make sense of all that data? Because, like, a simulation is only as good as your ability to actually understand what it's telling you. Right.
You're totally right. And DNeb's got you covered there too. Remember those XYZ files? The ones that are like flip books for how molecules move over time?
Right, right. Those ones always remind me of those flipbook animations where you can watch a little character walk across the page.
Exactly. And get this, DNeb can create animations from those files. So you're actually seeing how the atoms and molecules in your simulation are behaving instead of just like staring at numbers on a spreadsheet.
So instead of just reading about a dance, you're actually watching it, seeing how the atoms move, interact. That's incredible. It's like the data comes alive.
Exactly. It's way more intuitive, and you might pick up on things you'd never spot just looking at raw numbers. Patterns, trends, really helps with understanding.
It's like the difference between reading about a dance and actually seeing it performed. Makes all the difference. But I was looking through the DNEB info, and they mentioned something called custom parameters. What's the deal with those?
Ah, You found one of Deneb's hidden talents. It's super flexible. Like researchers can add their own special parameters, their own tags to the atoms and simulations. Really useful when you're doing really specialized research, stuff that's not already built into Deneb.
So say I'm working on a new type of solar cell, something super efficient, and I need to track specific atoms, the ones actually doing the energy conversion. I can tell DNEP to keep an eye on those.
That's it. You can tag those atoms, give them a specific label, makes it a breeze to track them throughout the whole simulation, see how they're interacting. It's like you're teaching Deneb to speak your research language.
Now that's what I call teamwork. No more sifting through mountains of data manually. DNEB's doing the heavy lifting, and I can focus on the big picture. Love it. Speaking of making life easier, the DNEB documents also mention some cheat sheets. Tell me more.
Oh, those. They're lifesavers, honestly. Great for new users, but even experts use them. They have those little reminders for everything. Keyboard shortcuts, common tasks, troubleshooting, like having a little helper bot right inside the software.
So thoughtful. It's those little details that make such a big difference, especially with these really powerful tools. It sounds like the DNEB team went above and beyond to make it user-friendly, maybe even enjoyable.
They did, and happy researchers do better research, right? But it's bigger than that. Making these powerful simulations easier to use, that has huge implications. Could really speed up scientific discoveries across the board.
Okay, I'm all ears. How does DNEB go beyond just helping individual researchers? What's the big picture here?
Imagine a whole new generation of scientists, right? They're not bogged down by the technical stuff. They're free to tackle big, important questions. That's what Deneb makes possible.
Like giving every researcher a high-tech lab right at their fingertips. What could that lead to? Like real-world examples.
Well, think about materials science. Deneb could help develop totally new materials with amazing properties. Things like lighter, stronger stuff for building spacecraft, or super efficient solar panels for clean energy. Even biocompatible implants, custom designed for each patient.
Whoa, we're talking about a materials revolution,
Yeah.
and DNEB's right there on the front lines. And it's not just the materials themselves, right? It's about scientists working together better, too.
You got it. Deneb makes it so easy to share everything, your setup, your results, all of it. So you can have scientists all over the world working together on the same project, sharing data and ideas seamlessly.
It's like this global network of scientists, all united by DNEB and their desire to learn. But is that always a good thing? Like, are there any downsides to sharing so much?
That's the million-dollar question. It's something we're figuring out as a community, how to keep things secure, protect people's work, and make sure everyone gets the credit they deserve. Those are solvable problems.
So finding that balance, right, openness, but with responsibility.
Absolutely. And platforms like Deneb can actually lead the way, build in features for secure sharing, tracking contributions, all that good stuff. It's a work in progress, but it's an exciting time to be in science.
Totally agree. So we've gone from the nitty-gritty of DNEB to its potential to change the world. But I'm sensing DNEB might have even more tricks up its sleeve. Like, you were hinting at applications beyond research.
Oh, yeah, for sure. Deneb's this really cool blend of visualization, data, and simulation. It's gotten people thinking, what else can we do with it?
Okay, now you have to elaborate. What other fields could benefit from a DNEB-style approach? Give me some examples.
Well, imagine what it could do for education. Like, think about how kids learn about science now. Deneb could make it so much more visual, more interactive.
Instead of just reading about molecules, they could build them, run simulations, and actually see how they behave. So much more engaging.
Right, and more accessible, too. Anyone with a computer and some curiosity could start exploring the nano world, even without being a scientist. That's pretty powerful.
It's like breaking down all those barriers to entry. So cool. But you also mentioned art, as in DNEB for artistic creation. Tell me more.
Well, when you think about it, Deneb's all about taking complex data and making it visual, right? And art is kind of like that, too. Whether it's pixels on a screen, notes in music, even how dancers move on a stage, it's all about data, in a way.
Whoa, I've never thought of it like that, but it's so true.
Exactly. So imagine artists using Deneb-like tools to create these amazing visualizations from data, or generate complex patterns, even choreograph performances based on how atoms move.
Okay, that's next level stuff. It's like we're blurring the lines between science and art, finding beauty in the smallest parts of the universe.
Exactly. It's about pushing those boundaries. Who knows, maybe the next big art movement will be inspired by the dance of atoms, all thanks to Deneb-like software.
That is an incredible thought. We've gone from DNEB's core features all the way to its potential to shape the future of art. This deep dive took us to some unexpected places.
That's the best part, isn't it? You never know where curiosity will lead.
So true. But for now, I think it's time to wrap up our DNEB deep dive as much as it pains me to say goodbye.
Agreed. We've covered a lot of ground, from the nuts and bolts of Deneb to its impact on science, education, even art.
We talked about making high-powered science accessible to everyone, speeding up discoveries, and maybe even sparking new forms of art. But most importantly, I think our deep dive shows just how powerful human ingenuity can be, especially when we combine our curiosity with incredible technology like DNEB. But before we go, we got to make sure our listeners know how to find out more, right? What if they want to give DNEB a try?
Definitely. Yeah. Talking about it is one thing, but experiencing it for yourself is a whole other level.
Okay, so for our listeners who are ready to take the plunge, where should they start? What's out there?
Well, the DNEB website is the place to be. They have a ton of information, all the details, tutorials, even examples of how DNEB is being used in the real world.
Sounds like a gold mine of DNEB knowledge. And from what you've said, it sounds like they've made it easy to find your way around, even if you're not a tech expert.
Exactly. And if you're more of a hands-on learner, they have video tutorials too. See everything in action, learn at your own pace.
It's like having your own personal DNEB guide. Okay, so to recap, website's the first stop, dig into the docs, check out those videos. Oh, and don't forget about the online community.
Couldn't agree more. Doesn't matter if you're a seasoned scientist, a student, or just curious about the nano world. DENAB has something for everyone.
It just goes to show great software can do so much more than just its intended purpose. It can inspire new ways of thinking, collaborating, and even creating.
Totally. It's about breaking down those walls between different fields. And who knows what incredible things will come from that. Maybe the next big breakthrough is just around the corner.
That's a thought to leave you with, but for now, we'll let you get back to your day. Thanks for joining us on this deep dive into the fascinating world of DNEB. We hope you learned something new and maybe even feel inspired to start your own scientific adventures. Until next time, keep exploring, keep questioning, and keep diving deep into those mysteries, big or small.